So interest. So you can model growth or decay by a constant percent increase or decrease with the following formula. So our final amount is A to the A of t, and it equals our initial amount, which is A, times 1 plus or minus, depending on whether you're increasing or decreasing. Increase is plus, obviously decrease is minus. And then we've got the rate of increase or decrease. That's going to be a percentage that we're going to turn into a decimal, and then the number of time periods. Okay, so in the formula, the base of the exponential expression, if I say 1 plus r, it's called growth rate. So this is growth rate, and that can also be called the annual rate of increase. And then obviously when we're subtracting, we're going to talk about decay rate, right? So things are going to be going down there. So this would be our decay rate. Because again, notice that minus right there. So this is our decay rate, or we can call this our annual rate of decrease. Annual rate of decrease or decay. So we're going to look at some growth and some decay problems that are word problems. So this says Claire invests $5,000 in an account that pays 6.25% interest per year. How much will she have in the account after 5 years? So the first thing we want to ask ourselves, is this an exponential growth or decay model? So is the money going to grow, or is the money going to decrease? Is it going to get more or less? So it's going to grow, right? So this is a growth function. And then we're going to write a function to model, obviously, the growth in the value of our investment. So we're going to do A of t, and that's going to be our base. That's going to be our initial amount, A, times 1 plus our rate of interest to the t power. So we're going to substitute the 5,000 into the initial investment. So our A of t here is going to be 5,000, okay, and then we're going to do our 1 plus, notice our rate of interest. So what we do to find this is we take this number up here and we divide it by 100. So if you don't know how to do that, or we move the decimal place 2 places to the left, so that's going to be 0.0625, and that's going to be to the 5th power. Now, sometimes you'll see this equation look like this: 5,000 to the 1.0625 to the 5th power. And it's important that you can recognize that those are the same thing. Okay, then we're going to do that. So what I actually typically do with this is I do the 1.0625 to the 5th, and then I multiply that by 5,000 when I do this in the calculator. So when I do that, I get $6,770.41. Okay. All right, so now you guys try this one and see if you can do it. Come back to me when you're done. So this one says in Australia 2002, in Australia, humpback whales population was 2,911 and increased at a rate of 14% each year since then. What is the whale population now? And it says we must find t first by subtracting 2002 from the year we're in now. But the other thing we want to look at is, notice here it says increase. So this is a growth function again. So when we write our function, our A to the t is going to be, and remember, we're going to divide this by 100 or move it 2 places to the left. So that's going to be 2,911 times our 1 plus 0.14. And then when we're looking for our t, this time we're going to subtract 2002 from 2022, and that's going to be 20 years. So we're going to take this to the 20th power. So here again, I'm going to rewrite this so you guys are familiar. 2911, and that's going to be 1.14 to the 20th power. Again, I would do the 1.14 to the 20th power and then multiply that by 2911. And when I do that, I get 40,007 whales. That's how many whales there is after a growth rate of 14% for 20 years. All right, our next one. This is our next example. It says the city population, which was initially 15,500, has been dropping 3% a year. Find the population after 10 years. Is this exponential growth or decay? So that says dropping here, you know. So this is going to be, write a function to model the decay, right, of the town's population. So this time we're going to subtract. So this is going to be A, and it's going to be 1 minus our rate of interest to the power of our time, right? So substitute A with the 15,500. And then that's the town's population. R with the interest rate. So then again, remember, we're going to divide this by 100 or move it 2 places to the left. So this is going to be 0.03 for the rate. And then T for 10 years, right? T with 10 for 10 years. Okay, so now we're going to actually write this out. So this is going to be 15,500. Now we're going to do 1 minus our 0.03. to the 10th power. So again, if I were to rewrite this, this is going to be 15,500 to the 0.97 to the 10th power, right? So when we do that, we're going to end up with 11,430 people in the town. When we've had a decay rate of 3% for 10 years. Okay? All right, let's see if you guys can do this one and then come back to me when you're done. So this says you bought an iPhone 13 for $1,300. So A of T here is going to be our initial amount that we paid. It says, yes, you are crazy. The phone depreciates at a rate of 5% a month. So this is 1 minus 0.05. And then how much is the phone worth in 6 months? Okay, so we're going to take that to the 6th power. So once again, this is going to be 1,300. And that's going to end up being 0.95 to the 6th power, right? So go ahead and do that in the calculator. And when you do, you're going to get $955.62. Okay? All right, now we're going to talk about compound interest. So when we deal with compound interest, it's very similar to what we did before. A is the amount earned. P is the principal, or the initial amount. R is our rate of interest. The difference is now, and T is our time in years, but now we have N is the number of compounding periods per year. So if we said that it's compounding annually, then our number here is 1. And if it's semi-annually, that means twice a year. Quarterly means 4 times a year. Monthly means 12 times a year, right? Weekly is 52 because there's 52 weeks in a year. And then daily would be 365. Okay? So remember, what we're going to do here, it's very key, is we're going to take our rate of interest and we're going to divide that by our N, which is the number of times it's compounded. But then we're also going to take 1 plus this, and we're going to take it to the N times T power. So we're going to do a couple of these together, and then I'm going to let you guys do some. All right, so first example here says, write the formula and complete the total. It says you invest $500 in an account that pays 7%. So our initial amount is going to be the 500. And this time we're going to do our 1 plus, and we're going to do our rate of interest. Remember, we're dividing this by 100, so that's going to be 0.07, and we're going to divide that by 1 because it's compounded annually, and that's our N. And then we're going to do our 1 times 8 years, okay? So here again, if I rewrote this, this is 500 times 1.07. 8 times 1 is to the 8th power, right? So when we do that and we compute it, we're going to get $859.09, okay? So now when we compound it semi-annually, it's going to be very similar. So we're going to have our 500. This time it's going to be 1 plus our 0.07 divided by 2. And then we're going to actually multiply 2 times 8. So here again, it would be 500 times 1.035 to the 16th power, okay? Now, obviously, you can take what's in the parenthesis, add it together, and then take it to the 16th power, or you can simplify it first. Doesn't really matter which one you do, okay? So now this one is going to be $866.99. And remember, whatever that next digit is, that's what you got to round with. If it's 5 or above, you round up. If it's 4 or below, you round down, okay? All right, here's our last one, 500 again, times our 1 plus 0.07. This time it's quarterly, so that's a 4, right? So, and then we're going to multiply that times 4 times 8. So when I divide 0.07 by 4, I get 0.175. So this is going to be 500 times 1.0175. And again, 4 times 8 is 32 to the 32nd power. Okay. So that is going to be, when we compute that, $871.11. Okay, so now, what do you conclude if the numbers are similar? So what can you conclude about these numbers? So when you compound it more frequently, the number absolutely goes up, but does it go up significantly or not? That's really the question. It does go up, but those are the things you need to consider when it's taught, when you go somewhere and they start talking to you about how they're going to compound your interest, okay? All right, so here's our U tries, A, B, and C. I would like you guys to write the formula and then compute the total amount, okay? So go ahead and do A, come back to me when you're done. We'll do that with B and C as well. So your parents put $5,000 in account for you when you were born. That makes 5%, and it compounds weekly. Okay, so it says, how much money will you have when you turn 16? Is it enough to buy a decent car? Okay, so we're going to take our principal again, which is our $5,000. We're going to multiply it by 1 plus our interest rate, which again, remember, we're going to divide that by 100 or move it 2 decimal places to the left, which is 0.05. And then we're going to compounds weekly, so that's 52. So that's going to be divided by 52. And then we're going to multiply that 52 times 16, because that's how many years it was right here. So that's our T, right? This was our R, this was our N, and this was our A, okay? So now when we compute that, we get $11,123.43. So do you think that's enough to buy a decent car? I think it depends on the kind of car you want. All right, part B. Again, I'd like you guys to read this, do it, and then come back to me when you're done. So you decide to put the money you got for your birthday, $750, in a savings account. So again, this is our A. That earns 2.5%. So this is our rate of interest. And remember, that's going to end up being 0.025, right? Because we're going to move the decimal place 2 places to the left. And it's compounded daily. So that would be 365. And that's our N, right? So this was our R, okay? And then how much will you have in 2 years? So this is our time, okay? So let's go ahead again, put this in our formula, 750. 1 plus 0.025 divided by what? 365 this time. And then we're going to take that to the 365 times what? 2, okay? So that's going to be equal to $788.45, okay? So again, remember, you can do this in your calculator by just doing 1 plus 0.025 divided by 365, and then take that to the 365 times 2 power, and then multiply that by 750. That's what I would do. All right, the final question. You win $500 and decide to put it in an account that earns 4% in an account that compounds monthly. How much money will you have in 5 years? Okay, go ahead and do this one. Come back to me when you're done. So again, our initial amount was 500, and it's 1 plus 0.04, because again, this was our A. This is our rate of interest, and this moves 2 places. So it was here, 1, 2, right? So that's 0.04. Compounds monthly, so that N is equal to 12. And then this is our T, right? Okay, so we're going to divide this by 12, and then we're going to multiply 12 times 5, right? So we're going to do this one. The answer is $610.50. And remember, you're always going to, whatever that third number is behind the decimal, if it's 5 or above, you're going to round up. If it's 4 or below, you're going to leave it what it is.